In this question, we pull a block at first stationary along a frictionless surface and we apply a constant horizontal force along the string. Okay, this constant horizontal force, right, is simply the tension in the string. Okay, so if we draw it on the body, right, it will appear as this. So this is the F, and we note, right, that is the X component of this force that is causing this block to accelerate. Okay, and the Y component, right, is not doing anything, so to speak. You can draw in the other forces as well. You see, this is mg, and you got to realize, right, that there is also normal contact force, and this normal contact force, right, is smaller than mg, such that, right, we have actually in the Y direction net force is 0, so you have actually n plus Fy equals to mg, but that's irrelevant to this question. Here, right, what we're interested is in the x direction, what's happening. So net force in the x direction equals to ma. So we have the Fx equals to ma. So what is this Fx? Well, you can simply, right, look at the diagram, right, a while later. So when the block, right, is somewhere here, the string will be along this direction. So if you draw in the same force, right, so the vector arrow has the same length, then you realize, right, at this position the Fx will have been smaller, whereas the Fy will have been larger. Okay, so with this, right, you can tell that Fx will actually decrease as this thing move along. Okay, will decrease with time. With that, right, you could already tell what will happen to the velocity, because, right, a decreases with time, or means, right, the gradient of vt or dv dt decreases with time. So which graph, right, shows you such a relationship? It has to be D. Okay, because, right, you see the gradient is actually decreasing, so that shows decreasing acceleration. Another way, right, if you would like to be more mathematical, you can also write out Fx in terms of F and the angle theta subtended by the string to the horizontal. So you will have F cos theta equal ma. Okay, and you can also see from here, right, that the theta the theta will increase. That makes, right, the cosine theta smaller and a smaller, but you don't actually have to do that. Okay, so answer is D.